In the beginning of this video, I'm going to attempt to finish this entire practice quiz at record's pace. Not a real record, I'm just going to do it fast. This is not my document. I did not create this. Outside of importing it, I have not looked deeply into any single problem. I have a timer in the top right. After this, I'm going to do all the problems over again. Like, with you. I'm going to show you how to do them. This is kind of one of those, this isn't a show-off thing. This is more one of those, this is possible to do. Like this. Okay, ready, set, go. All right, here we go. Uh-oh. I'm not going to box anything here. Shoot. No. Okay, I got it. Got it. Okay. Shoot. Okay, these are both plus 2. That's fine. Minus 12. Shoot. 4. 4, 3, 4. Shoot. 6, 18. Okay. 6, 6, 6. 6, 2. Oh, this might not be factorable. This might not be factorable. 4y, 1y, minus 1, minus 2y. Oh, it's definitely not factorable. That's a minus. Okay. I'm going to guess this one's not factorable. I'm going to put prime. I did see this said if not factorable, right? Not factorable or prime. So I think that one's not factorable. I'll go back into that when we go over it. Okay. 5, 5. Okay. X minus 20. 5x, x, plus 10, minus 2. Okay. I'll box that because that's the answer. I hope not a lot of these are not factorable. I hate jumping through hoops to see. See, I think this was also not factorable as well. When this sum is too low, I think this is also not factorable already. Can't be AP or P before P. It's got it. Yeah, that's prime. I don't like the problems when they're like that. For the sake of having you guys practice more stuff. All right, x squared. 6, 6, 6, 6 squared. 3x squared minus 16x. Oh, no, 6 couldn't factor out of 32. Shoot, let me do that again. So a 2, oh no, 2x squared. So 9x squared minus 24x plus 16. Oh, wait, 3, 4. Oh, good. Perfect. I thought it was going to be one of them hard ones. Whoa. Oh. Messing up my record pace. Okay. Oh, I didn't know there's a word problem here. Okay, if the area of a rectangle is modeled by the expression. Okay, it's just a model. Use factoring to help you find the 5x. Area equals 55 square inches. The area can be modeled by this. Okay, this equals 55, so x squared plus 3x minus 15 equals 55. Subtract 55x squared plus 3x minus, okay, that's fine, equals 0. X plus 10, x minus 7 equals 0. X equals negative 10 equals 7 square inches. So all right, done. All right, stop. Done. All right, cool. Well, hello and welcome you to Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you, as it is every day here in my virtual math classroom. Now, I just went and spent about 5-ish minutes kind of working on a quiz thing there, practice quiz, I should say, for my group, for my kiddos, Integrated Math 2. I'm going to do this one more time. I actually set up a page after to kind of like a splash screen to show different things that we want to be looking at here. I kind of wish none of those were not factorable. I wish all those were factorable. I don't want to run into some, and I can explain why those were pretty quickly, easily non-factorable as well when we do it. But anyway, I'll run through those. I'll do those again, like in a kind of way to explain what we're doing there. Sometimes I'll intentionally do some wrong stuff, maybe because my mind likes to look for the right stuff first, and I'll say what your mind wants to go through sometimes if it does something wrong, which is okay. All right, so I have this next page here that I did make, and I'm going to show you right here. It looks like this. So a few things. Oh, let me hide that time now. We don't need the time anymore. So golden rule of factoring here, always seek greatest common factors first. Every single time I'm factoring, I'm always looking to see if I can pull something out. A 2, an x, a 2x, you know, something. Divide that out. It's going to make things a lot easier, and you're kind of required to do it anyway. But it is, with both those things combined, you always look for those first. Doesn't matter what kind of problem it is. Always, always, always look for those first and factor them. The whole x squared plus bx plus c stuff, there it's all kind of written here. We do try and find two numbers that multiply to make c and add to make b. First, look for your factors of c. It doesn't matter if your c is positive or negative. Just list your positive factors first. And then what you do is you can look at the signs of c and b after that. And say, if c is a positive number, either both factors will be positive or both will be negative. If your sum is positive, both are positive. If your sum is negative, both are negative. Kind of nice. However, if your product's negative, now it's one positive, one negative, and if the sum is negative, then the larger value is positive, and then the smaller number is negative, but the sum is negative, the larger number is negative, the smaller is positive. It kind of helps filter out things. Instead of doing 4 times as much work, potentially, you can just do a quarter of the amount. You know what I mean? So there's that. Now, if it's an ax squared plus bx plus c, this part is definitely still true right here. This part might not necessarily be. I'll kind of explain why when we're doing it, but we do know one will be a plus, one will be a minus there. Some other stuff that might show up here. I don't think I did this too much when I was just doing that quiz right here. Knowing that an even plus an even is an even, odd plus an odd is an even, just things like that. Just kind of look at these. This is multiplication. These things are true as well. Anyway, I just want to make sure that you're just aware of the idea. I'm going to be talking about evens versus odds sometimes to understand what I know can work or can't work. And then last but not least, perfect square trinomials. Oh, you know what I didn't write? Hang on, I'm missing one. I am missing one. My bad. Let me kind of shift some things up because I manufactured this. Because I didn't know what this quiz was going to have, and I forgot about difference of two squares. So a squared minus b squared equals a plus b times a minus b. Whoops, a plus b. Let me do that again. Plus b times a minus b. There, I forgot about that one. So that one's jumping into play as well. My bad for not including that. Perfect square trinomial, whether you're adding a plus b or you're doing subtracting a minus b quantity squared, it becomes one of these. But of course, we're going to go from this form to that form and difference of two squares as well. Okay, I'm going to go ahead and get started on the actual problems. Again, this is a blank slate. Factor completely, if not factorable, right not factorable, or prime. Unfortunately, I think I did run across two, but I'll double check and see if that happened. Okay, so the first problem right here, this is an x squared plus bx plus c. I am looking for two numbers that multiply to make -5, and add to make +4. And in doing so, I list my factors of 5. Well, my factors of 5 are 5 and 1, and that's it, because 5 is a prime number. Now, because my product is negative, one of these is going to be positive, one's negative. Because my sum is positive, the smaller one's negative. So 5 minus 1 is 4. That ends up being the answer. So 5 and -1 are my two numbers. If I did this right the first time, I should have gotten x plus 5 times x minus 1. I was going to say x minus 4. That should have been my answer there. I'm not going to check them all just to make sure x plus 5, x minus 1. There we go. Now, number 2, there are two different ways to do number 2. One is recognizing this is a difference of two squares, meaning this is some sort of, a squared minus b squared, like that. All right, x squared minus 4 squared. If that's the case, that means this factors down to a plus b times a minus b, like that. And you're set. You should recognize this is a difference of two squares. A few things occurred. Number 1, two terms. Number 2, they are perfect squares in and of itself. X squared is 1x squared is 1x quantity squared. 16 is 4 squared. Number 3, there's no linear term, things like that. So a lot of things kind of jump out at you when you recognize this is a difference of two squares. But let's say you don't know the formula or how the thing works. What you could also do is you could rewrite this as x squared plus 0x minus 16. And you can work it out the same way we worked out this diamond before. Find out what two numbers multiply to make -16 and add to make 0. And it's understanding that I'm writing that 0, that's the linear coefficient. We're still trying to find the sum of that. That would be 4 and -4. They have to be additive inverses to add to make 0 and multiply to make a non-zero number. And that's 4 and -4 there. And that's where you can get your x plus 4 times x minus 4 again. So it's possible to go that way. Lastly, same thing here. You could go into the diamond here, but before I actually do this diamond, if you can recognize this is a perfect square trinomial off the bat, go with it. And if you sometimes, I know a lot of my perfect square trinomials, so I just know this is. But on top of it, if you recognize that this is indeed x being squared, on the other end is 5 being squared, and if in the middle you are doubling the product of x times 5. If you recognize 10x is 5x doubled, then you do have a squared plus 2ab plus b squared, which means this becomes x plus 5 quantity squared. Now, when you saw me do it not in the video, just earlier in this video, I saw it, I did it really immediately there. So my recognition of it was squared away. And again, I promise I did not see this worksheet before. This is something, you can give me a brand new worksheet. I'll be the same speed. Okay, so other alternative is 25 and 10. What two numbers multiply to make 25 and add to make 10? Your factors of 25 are 5 and 5 or 25 and 1, and you find out that it's 5 and 5. So 5 and 5, and then you maybe say something like, okay, well that's x plus 5 times x plus 5. Well, x plus 5 times x plus 5 is indeed x plus 5 quantity squared. That's what it simplifies to. Either answer is acceptable, but you probably want to recognize that this is also what it becomes. When my classes start doing completing the square, they're going to want to know about this part anyway, and this part anyway. So it's going to come into play. Okay, number 4. This is where we start to get a little bit more peculiar. There is a diamond method involved. I'm not covering it. It's something called factoring by grouping. I do mental factoring with my kiddos. That's what I did when I was doing this problem. I forget if this is the one that's factorable or not. I think this is factorable. So on number 4 here, if it's factorable, I know I'm going to break it down into something here. Like, boom. Even the ones that weren't factorable, I tried. I said, if it is, it'll break down like this. My first terms have to be some 5x times x. Because 5 is a prime number, it has to be this. I don't know what the signs will be here, but because it's a negative product, I know one of these is a plus, one of these is a minus. I do them in my head personally myself first. I ask my students to consider writing stuff down so they can start testing. So if my students were doing this, they can write a plus or minus here. And if they're wrong, they can switch the signs. I'll show you what I mean by if they're wrong. It's okay. They don't have to test more points. They're going to try and get a positive or a -6 here. If they get a negative, they don't have to switch the signs. If they get a positive, they'll have to switch the signs. 8. 8 can either be 8 times 1 or 4 times 2. Now, I know that it's going to have to be 4 times 2. This goes back to the even odd stuff that we were talking about. I might have even said that out loud, like when I'm whispering my thought process, I might have talked about 2 and 4 in my head. 6 or negative 6 is an even number. 5 is odd. 1 for 1x is odd. And if I choose 4 and 2 here, those are even numbers. Even, even. When I FOIL and I do outside times inside, I'm doing odd times even, which is even. I'm doing even times odd, which is even. And I'm doing even plus even. That gets me even. 4 and 2 will give me even. But if I have 8 and 1, 8 and 1, whether it's here or the other way, I'm doing an odd times... Oh, sorry, that is still even. I'm doing an odd times an odd somewhere. I'm either doing 5 times 1 or I'd be doing 1 times 1. Either or. I'm getting one of them is odd, the other is even. Odd plus even is odd. That doesn't work. Anyway, that's me. That's my explanation was longer than the actual way to go about doing this. And so anyway, I don't know if it's 4 and 2 or 2 and 4 yet, so I try one. If I try 4 and 2, 5 times negative 2 is negative 10. 4 times 1 is 4. Negative 10 plus 4 is negative 6. Hey, that one worked out. That one's actually the answer. And the signs stay exactly where they are. So this is the answer, 5x plus 4 times x minus 2. I want to double check these. I do these in my head, so I don't know. I haven't done these in a while. 5x plus 4 times x minus 2. There we go. See, if I put the 4 here, I'm doing 5 times 4, which is 20. I knew I couldn't get too large. I probably even tried that immediately. I first tried 2 and 4, got 20. It's not going to work. Try 2 there. Things like that. Okay, number 5. Let's check this one out. If it's factorable, it's going to break down into something times something here. 15x squared can either be 15x times 1x or 5x times 3x. I think that I rolled the dice and I kind of landed. I like to try the closer, smaller numbers. I like to try 5x and 3x first. I don't like to get too rambunctious with the 15 stuff. Because I know 15 times 4 is 60 already. That's too big, things like that. I don't know if I forget what the answer is already with this, so it's nothing here. But 5x and 3x I'm going to try first. 4 can either be 4 and 1 or 2 and 2. Now this goes back to the same thing about even one more time. 16 is an even number. If I use 4 and 1, no matter which order they are, I'm doing odd times odd somewhere, which is odd. Odd times even, which is even. Odd plus even is odd. That's no good for 16. We need an even number. That's why I need a 2 and 2. I needed 2 and 2. I think I got stuck for a second asking, am I placing things in the right spot if I try 2 and 2? I just said spot if I try 2 and 2. And I think this one just worked out. 5 times 2 is 10. 3 times 2 is 6. 10 plus 6 is 16. That gets me that. The alternative was trying 15 and 1. That would give me 30 plus 3. And that's 33. 30 plus 6. And that's 36. It's too large. So that's the answer there. That was, it's not, that was trial and error, but I knew that 4 and 1 weren't going to work, so I wasn't going to try it at all. That would have just led to error there. So 5x plus 2 times 3x plus 2. All right, this next one, you probably saw me write this in standard form. Personally, I need that. I need standard form here. So I need 3z squared minus 20z plus 12. I need the appearance of my quadratic term first, and by and large, is probably the best way to go about it anyway. So anyway, when I factor this thing, if factorable, I know there's going to be a 3z times a z that gets me 3z squared. Positive product and negative sum means I will have a negative times a negative, so I don't have to worry about signs. I know it'll be this. Now 12 can be 3 times 4, 6 times 2, or 12 times 1. If it is, this is the nice thing about this being a 3. First of all, there's no common factor among these. No greatest common factor here. If I have, so 3, 4, 6 and 2, 12 and 1, I don't probably write in that order. I know that I could not write the 3, the 6, or the 12 right here because all of these numbers are divisible by 3. And if I can factor a 3 out of this individual quantity, okay, if I can factor 3 out of this individual quantity and I couldn't out of the original expression, individual inequality, and couldn't, I'm sorry. Let me say that one more time. If I can factor 3 out of this individual inequality, it's late. If I could factor a 3 out of this individual quantity, but I could not out of the original expression, something's wrong. And the thing that's wrong is none of these numbers could work here. They could go over here. I could possibly have a 3, a 6, or a 12 over here. Meanwhile, I can test a 4, a 2, or a 1 inside here. So I'm going to first test 4 and 3 right here. Now, same thing applies to the 20 here, being that 20 is even. I shouldn't be testing 4 and 3 because I have an odd plus an even. That's odd. That's not going to work. No matter what, I'm not even actually trying the numbers. I know that's not going to work. 1 and 12 also won't work for the same reason. I'm going to have an even plus an odd in that category. The only chance is even plus even. This is the only way it's possible. If this doesn't work, it's not factorable. 2 and 6. Negative 18 minus 2. That's negative 20. So that's the only one that works. That might have been the first one that I tried, again, for the same reason. I looked at evens. I looked at the 6. First of all, I need to get to negative 20. I need to get to a big number. So I'm trying to get my bigger numbers to multiply together, like 3 times 6, to get closer to 20 if possible. But also I knew that I couldn't place a 6 inside here because I can't factor 3 with 6. I'm not allowed to if I couldn't before. So here's the answer here. 2, 6. Sorry, there it is. 3z minus 2 times z minus 6. 3z minus 2 times z minus 6. There it is. Okay. Number 7. Ooh, this is one of the first non-factorables. So, okay, playing with it to start, you're saying if it's factorable, it's this and this. You know, I started writing some stuff out because that's just my go-to. I really should have noticed immediately. Here's the thing. These are both minuses for the same reason these are both minuses here, because negative sum, positive product right here. Now, the problem here is that whether they're both negative or both positive, see, if this was negative, then there's a chance it's factorable. But because the product is positive, that means these are both negative or both positive. Whether they are both negative or both positive, the idea is you'll go further in that direction. You'll continue further in that direction. Meaning, if it was a positive 3 and a positive 9, whatever, it goes further that way. Or negative 3, negative 9, go further that way in terms of adding. Negative 3 plus negative 9 is negative 12, things like that. Here's the problem. I wasn't sure what to put here. 2 and 2 probably, or 4 and 1. I guess I would have had to do 2 and 2 here because 7 and 1 would have to go here. That way I have an even plus an even. But the problem is these numbers are going to go further negative. 2y times negative 1 might be negative 2. 2y times negative 7 is negative 14. Negative 2 minus 14 is not negative 2. This is going to get too far away. I mean, these are the only numbers I should test here because 7 and 1 are prime. And because 2s are evens, I need to get even back. 4 and 1 would have given me an odd combination. I know I keep saying the even odd stuff, but I promise that is a big talk. That is a big talk of understanding the concepts of, you can eliminate things like 4 and 1 there. Because the 2s are the same, doesn't matter where I put the 7 and the 1s, especially since signs are the same. That gives me negative 16. That number's going to get way too large there. It's not going to work. This one does not work either. This is not factorable. This thing is prime. That's still my go-to with that. This negative 2 is way too small for a positive product to keep my number in my sum that small. It's not going to happen. I just tested the only thing that was worth testing. 4 and 1 is not worth testing because that'll leave me with an odd sum. This is the only one. Didn't work. It's prime. Okay, the next one here is, once again, recognition of possibly difference of two squares. 25 is 5 squared, 16 is 4 squared, a squared is a squared, and b squared is b squared. So if you can recognize right here that this is 5a quantity squared minus 4b quantity squared, you're looking at a difference of two squares right then and there. So this becomes, this is the whole a squared minus b squared is a plus b times a minus b. So 5a quantity squared minus 4b quantity squared is 5a plus 4b times 5a minus 4b. This is really, I'm not going to say this is the only way to do the problem. Outside of doing factoring by grouping, this is really the only way I would want to look to do this problem. I wouldn't want to look to put a 0ab inside the middle and try and play with stuff there. I'm good with that, leaving it as quick and swift as possible. All right, number 9 is the first one where I can see a common factor here. The first thing I saw was a 5, and after that I saw the x's. I don't know why I didn't see the x's first, especially with an x cubed. But I can factor a 5 and an x out of here to begin with, and you always seek greatest common factors first. Golden rule, always seek them first. That way we can actually factor the rest properly and easily, significantly more easily. I factor 5x out of here, I'm left with an x squared. I factor 5x out of here, 5x times 8x is 40x squared, and 5x times negative 20 is negative 100x. So now I got to see if I can factor this inside part right here. Now, if I couldn't, that doesn't make this factorization prime. I already did some factoring. However, there's more factoring that can be done here. What two numbers multiply to make negative 20, and add to make 8? Well, my factors of 20 are 20 and 1, 10 and 2, and 5 and 4. All right? Negative product, one's positive, one's negative. Positive sum, smaller numbers negative. Subtract, subtract, subtract. 20 minus 1 is 19, 10 minus 2 is 8. Bingo, 10 and negative 2. So 10 and negative 2 go there. Those also end up being the factors within. Again, when it's a 1x squared, I can play this game. Straight up, the p and q are my factors of this thing right here. X plus 10 times x minus 2. By the way, that 5x sticks on the outside. That does not go away. All right, number 10. Ooh, okay. So I think number 10 was the same kind of thing as number 7. I can't go back to play back my recording of the things. I'm still in the same recording. But I was kind of playing this and saying, this is probably not factorable for the same reason. This sum is too small for a positive product, meaning both are going to be positive with this positive sum. This sum is way too small given the numbers that I have here to be able to leave my sum as low as 3. Remember, when I factor this thing, this either has to be 8p times p or 4p times 2p. 8p times 4p times 2p. Now you can imagine, based on what I've mentioned before, which one it would have to be. It cannot be 4p times 2p, because otherwise I'd be doing an even plus an even. See, once these numbers are even here, even times even is even, even times odd is even. So I'd be doing even plus even. Guess what? I need an odd number. So already I know it couldn't even possibly be that. 8p times something is going to make that number 8 or larger. And I can't go back down to 3 because I'm only adding. I'm only getting larger. This wouldn't be possible. That being said, if you try to test it, you can either try 2 and 1 or 1 and 2. But can I do 2 and 1? No, because 2 and 8 have a common factor of 2. This does not have a common factor of 2 here. Therefore, 2 and 1 wouldn't have even been possible. The only thing I should have ever bothered testing to begin with was this one right here. This is the only one to try. The 4p and 2p, no, because evens. 1 and 2, no, because no common factor of 2. Therefore, this is the only one worth testing. 8 times 2 is 16. Plus 1 is 17. Nope, that's not 3. Doesn't work. Prime. Not factorable. Not factorable. This was the one to test. It didn't work. Number 11, I started by trying to factor out a 6. I don't know what got into me. 32, you cannot divide 6 out. And I was thinking, oh, this is going to leave me with big numbers. Again, this is my first time doing this. So I said, this is going to leave me with my big numbers if I only can factor out a 2. I could factor out an x squared, though, of course, because I need to get a quadratic. So I said, I got a 9x squared here. That's 9 and 1 and 3 and 3. And then I have a 24x here, pretty big. Once I got this 16, I started to feel a little good about things because I saw this is a perfect square. This is a perfect square. My question to myself was, is this double the product of the two numbers that I had squared to get this? Let's see. My answer to myself was yes. I'm going to double check this. I believe it's correct. Even in my head, I'm believing it's correct here. So 9x squared is 3x, quantity squared. 16 is 4 squared. Now I can subtract here because the rule for the thing, I can do a minus 2ab. This will be a minus b quantity squared. The question is, in subtracting this, am I doubling the product of 3x and 4 right here? I always run out of room there. 3x times 4 is 12x. Double that is 24x. So yes, I am doubling the product. Therefore, this is a perfect square trinomial. And as a perfect square trinomial, a squared minus 2ab plus b squared, that breaks down to a minus b quantity squared. Yes, you can play with this and try and choose, you can say this breaks down to this times this, and you can play with 3x and 3x or 9x and 1x, and then 4 and 4 or 8 and 2 or 16 and 1. And then I'd probably tell you some things about, here are different ways that you can make this thing an even number based on blah, 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 blah. Honestly, their only way would be with the 4 and 4. But anyway, so that ends up being the breakdown here, though, once you get that, if you recognize the perfect square trinomial. All right, back page. Back page has solving equations. You still factor. Your goal in this is to set the equation equal to 0, factor, use zero product property, and solve those other parts pretty basically here. This is already set equal to 0, so my goal is to figure out with a 1x squared what two numbers multiply to make positive 6 and add to make negative 7. Well, it's either negative 3 and negative 2 or negative 6 and negative 1. I know they're both going to be negative because positive product, negative sum. And those are my factors of 6. So either negative 3, negative 2, that's negative 5. Negative 6, negative 1, that is negative 7. So negative 6 and negative 1. So that becomes x minus 6 times x minus 1 equals 0. The zero product property then states if a times b equals 0. Ooh, I didn't write that in my thing here. I really should have. See, I didn't know what was coming up. I thought it was only factoring. I don't know why. I knew I was going to quiz my students on solving here. So let me write this down here. If a times b equals 0, I'll let you know, I whipped this up really fast. Then a equals 0 or b equals 0. There we go. That's another thing I forgot. Zero product property states that if I have a product that equals 0, and I do, this times this, then that means either this equals 0. If I add 6 to both sides, I get x equals 6. Or x minus 1 equals 0. If I add 1 to both sides, I get x equals 1. So this or this is the correct solution set to the original equation here. Next one, x squared plus 2x equals 35. I know I always say seek greatest common factors first. However, if I factor here, x times x plus 2 equals 0, or excuse me, that doesn't equal 0. This is the problem. If I say this and it says equals 35, see, there is no 35 product property, so this doesn't allow me to do what I want to do. I'm talking about always seek greatest common factors when you're dealing with your quadratic trinomial. Let's make it 1 first. Set this equal to 0 to begin with. Subtract 35 over, and then check, is there a greatest common factor among all your terms? No. So you play your factor game. What two numbers multiply to make negative 35? You'll notice when I did this, guys, I never draw this diamond. I'm giving you the visual so I can ask the question out loud, because I know some people just need this. What two numbers multiply to make negative 35 and add to make positive 2? Your factors of 35 are 35 and 1, or 7 and 5. Negative product positive sum means negative number is smaller. 35 minus 1 is 34. 7 minus 5 is 2. It's going to be 7 and negative 5. 7, negative 5 are your two factors. So this becomes x plus 7 times x minus 5 equals 0. Now that it's set equal to 0, we can use the zero product property now that this is a product, and either x plus 7 equals 0. If x plus 7 equals 0, subtract 7 from both sides. X equals negative 7. If x minus 5 equals 0, you can add 5 to both sides. You get x equals 5. Those are your two possible solutions for the original thing. Let me double check one of these with you guys. Negative 7, if I substitute negative 7 in here, I get negative 7 quantity squared plus 2 times negative 7 equals 35. Negative 7 quantity squared is positive 49. 2 times negative 7 is negative 14. 49 minus 14 equals 35. Yeah, 35 equals 35. That one checks out. Let's try 5. 5 squared plus 2 times 5 equals 35. That's 25 plus 10 equals 35. Yep, 25 plus 10 equals 35. 35 equals 35. That checks out. Those are the only two solutions to this original equation there. Yeah, you could plug it into these ones as well, but your double check is the original. All right, number 14, 6x squared minus 13x equals 5. Same thing. Let's set this puppy equal to 0 first. Subtract 5 over, and then play the factoring game. Now, this is one where, unfortunately, I couldn't determine, because this thing's odd. You're talking about, hey, even, odd, stuff like that. Unfortunately, factors of 6 are an even with an odd, or an even, or an odd with an even. So it doesn't change the idea of what's going to happen here, especially since 5 is a prime number with only odds 5 and 1. So I didn't know which set it was going to be yet, 6x and x or 3x and 2x. Off the top of my head, I still don't remember. So right now I'm just going to try 6x and x and see if I get anything. So -5, either -5 times 1, 5 times -1, things like that. So I can either do like a +5 -1, something like that. But you'll notice here, that's -6 plus 5, that's -1. That's not going to work. And if I switch these, if I switch the 5 over here, now you're looking at, it doesn't matter if plus or minus, doesn't matter. We can switch the signs later. That's a 30. 30 minus 1, no, that's not going to get you 13. So it doesn't look like it's 6x and x. So I'm going to try, whoa, that's weird, sorry. I'm going to try 3x and 2x now instead. And because 5 and 1 aren't common factors of 3 and 2, you can place this in either spot. But we're trying to get -13. I want to try and multiply the 3 by 5 right here. That'll give me 15. I can subtract 2. Boom. Oh, I need to add 2. This is backwards. So here's a good example. 3 times 5 is 15. 2 times -1 is -2. 15 minus 2 is positive 13. I need a -13, so I got to switch these signs. +1, -5 right here. So +1 minus 5, -15 plus 2 is -13. That's good. It's factored. I'm not done though. I need to solve this thing. I need to solve for x. I did create a product, set equal to 0. So either 3x plus 1 equals 0 or 2x minus 5 equals 0, okay? Subtract 1 from both sides and then divide both sides by 3. I got x equals -1/3. I'm going to have to double check I got that answer. Add 5 to both sides and then divide both sides by 2. X equals -5/2. Those are my two possible answers there. I didn't write ors the first time just because the clock. Sorry about that. -1/3, +5/2. Let's see if I got that. Yep. Okay. So you'll notice how I'm playing with these things here. Lastly, well, not lastly, I have a word problem, but the last one I have here, a 2 can factor out. Factor out the 2, x squared plus 6x plus 9 equals 0. Personally, I divide both sides by 2 automatically. I think I left the 2 in there the whole way for you. Otherwise, you're like, where did it go? What did you do? So I left the 2 on the outside. But you can divide both sides by 2 right now. Divide them by 2, boom. You get x squared plus 6x plus 9 equals 0. We're still trying to solve for x. This is a perfect square trinomial. Whether or not you notice what two numbers multiplied to 9 and add to 6 is 3 and 3, I also notice this is x being squared, 3 being squared, and of course double the product of x times 3. Double the product of 3x. You'll probably also notice I didn't write this when I first did it, but this is x plus 3 quantity squared. This is not so much a product of two things. It is x plus 3 times x plus 3. But if something squared equals 0, then that something needs to be 0. X plus 3 has to be 0. There's another way to do that, taking the square root of both sides, but we're not there yet. Subtract 3 from both sides, x is -3. That is the only answer. This is said to have what's called a multiplicity of 2. You can ignore what I just said right there. That's going to matter in pre-calc, maybe in some algebra 2 for some people. Anyway, there's that answer there. And the last one, number 16, it was a word problem, but they give you the model, and they're just asking solve for x. Well, sort of. There's a kind of part in the final answer that I want to cover. You probably saw me cross out an answer. I'm going to talk about that. If the area of a rectangle can be modeled by the expression x squared plus 3x minus 15, use factoring to help you find the value of x when the area equals 55 square inches. I'm actually going to do you one better after this. I'm going to show you what the heck that breakdown is with a picture. I was just working on a time crunch. So if the area of this thing here is x squared plus 3x minus 15, that's going to be some sort of base times height that equals that. Now, our area is also 55 square inches here. So I'm going to set this equal to 55. X squared plus 3x minus 15 equals 55. Now, this is not what I do. Oh, wait. Actually, that's not factorable that way. You know what? Forget what I said about the thing here. I was going to factor this equal to 55 and show you that means it's some base times height. This isn't factorable. This here isn't factorable. When I subtract 55 over, it does become factorable. Ignore what I said about the area thing. I guess I'm not going to do it that way. I was going to show you what the base and height were after I solved for x, but because it's not factorable, that means it's irrational numbers, and I'm not going to play that game right now. But I am going to set it equal to 55. X squared minus, plus 3x, excuse me. 3x minus 15 equals 55. Set it equal to 0 like the other one. Subtract 55 from both sides right here. Negative 15 minus 55 is negative 70. So x squared plus 3x minus 70 equals 0. What two numbers multiply to make negative 70 and add to make 3? You know, it does help to try and do some of the obvious ones, like 7 times 10, you know. That being said, I'm going to list all the factors of 70 just in case it may be something else. 70 and 1, 35 and 2, divide by 5. Excuse me, not 5. Yeah, 5. 5 and 14, and 7 and 10. Okay. So those are the ones. Negative product, positive sum. Once again, subtract the small ones. 69, 33, 9, 3. This one gives you 3, 10, and negative 7. So that becomes x plus 10 times x minus 7 equals 0. If x plus 10 times x minus 7 equals 0, then either x plus 10 equals 0, subtract 10 from both sides, x equals negative 10, or x minus 7 equals 0, add 7 to both sides, x equals 7. Now here's the thing. This is a word problem. This talks about a physical object. Area of a rectangle can be modeled by this, blah, 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 to help use factoring to help you find the area when the area equals 55. You know, I'm at pause with myself again. So you probably saw me last time cancel negative 10. Here's what I was thinking about. I was thinking about x representing portion of a physical length if I factored this, which I didn't the first time, but if I factored this and it's not factorable, then I would have had a length involving x with a negative number. I can't have negative lengths. You know, that's the problem. I don't want negative lengths. It wasn't factorable, though, and that's what makes this kind of weird for me to talk about. If it wasn't factorable, that means that this x being negative 10 is not relevant to this thing. So what I was going to say is that in a real world word problem, if this was about lengths and about x representing portion of a length, I can't have a negative length. That's why I was crossing that out. For the sake of this stuff, it looks like because it wasn't factorable to begin with, I don't know if negative 10 is actually a problem. It might still be allowed. They're not talking about x in terms of length, and I couldn't factor it to represent it as a length for you to show you that. Therefore, negative 10 is probably acceptable. Probably acceptable. In other circumstances, though, maybe not. So me crossing it out versus not is kind of, it's a question mark. It's a question mark. But that is the last problem there. All right. So anyway, that'll do it for this one. Clearly, as I explained, it took a lot longer to do instead of the 5 minutes, 43 seconds that I got it done. I hope this was helpful for you. This is kind of a late night video. Sorry about that. Take care. Good luck.